Greetings to all of you. In today's session, we are going to discuss about the intermediate chemistry, which is helpful for the international entrance or any competitive exams you are aspiring for your higher education or else any kind of career opportunities. In addition to that, India level JEE Mains and JEE Advanced examination to enter into IITs and NITs technical stream engineering sector, and also NEET Chemistry for medical entrance examination throughout India, Telangana and Andhra Pradesh EAMCET Examination for engineering entrance. For all these, the kind of session will be very much helpful. In addition, if you are aspiring for any government jobs, any government job entrance examinations, the kind of session will be very much helpful. And the questions, whatever mentioned here, are retrieved from various previous year question papers, and detailed explanation will be provided to you. I will assure that the kind of session will be very much helpful for your further preparation. Whatever you are aspiring for, that will be definitely in front of you by a serious preparation towards this one. Let's enter into our question number 1. Here, this is the session will be started with the IUPAC nomenclature of the given organic compounds. If you see, these many compounds are provided. If you follow the regular guidelines related are given by the IUPAC nomenclature, it is very easy to give the naming for all these compounds whichever given. Here in the compound number 1, you can find double bonds only. And the entire system is said to be 1, 2, 3, 4, 5, 6 carbon 1, and where first carbon and this fourth carbon are having double bonds, and in the second one, triple bond and double bond both are present. So if triple and double bonds are present, this is a competing factor and which will get the priority we have to discuss. And next is about triple bond is there, double bond is there, which end we have to start numbering, that is also matters. Another one, you can find the double bond on one carbon, methyl on the another carbon, which will get the priority to be the part of this one. And if this is the length of the carbon chain, what will be the suitable order of numbering to the parent chain over here? That also matters in case of this kind of compound. And another cyclic compound, in the cyclic compound, how the numbering and followed by naming is given, we have to predict. Let's go one by one. In the compound number 1, here first carbon is accorded with double bonds, second, third and fourth. 1, 4, 2 double bonds are there, and being it is the carbon chain of 6 carbons, here the name will come as a hexa. And first and fourth carbons 2 double bonds, so that we can say diene. Position of the double bonds are 1, 4 hexadiene. This is a complete IUPAC name of the compound number 1. Move on to compound number 2. You can find double bond and a triple bond. Obviously, double bond will get the priority over triple bond. But in case of this compound, double bond, if you start numbering from this end, double bond is located on the second carbon. If you start numbering from this end, triple bond is located on the first carbon. So that least priority, less numbering should be accorded. So that we will start numbering from the right hand side. 1 carbon is having triple bond denoted with the ine, and the third carbon with the ene, so that ene is given in the third carbon, being it is the carbon chain of 5, so that penta is the parent chain length. So let's name this. Ene will come first over ine as per the alphabetical nomenclature. That's why ene should be pronounced first. Though it is in third carbon, we have to pronounce ene first, later on ine should be denoted, right? So in this manner, 3 third carbon is having double bond, and being it is the 5 carbon chain, pentene can be given, and first carbon you can find triple bond denoted with the 1-ine. 3-pentene 1-ine is the complete IUPAC name of the given organic compound. Move on to compound number 3, where you can find 1, 2, 3, 4, 5, 6 carbon. Competing factor is there, double bond on one end, triple bond on another end. Obviously, double bond will get the priority over triple bond, so that we have to start numbering from this end. If you go with numbering in another manner, 1, 2, 3, 4, 5, 6, 7 carbon chain it might be. 1, 2, 3, 4, 5, 6 carbon chain. So that here numbering will be in this manner. 1, 2, 3, 4, 5, 6 will be there. If you see, fifth carbon is having ion. Fifth carbon ion is indicated. First carbon, third carbon. First and third carbon double bonds are there. And being it is a length of 6 carbons, hexadiene can be mentioned. 1, 3 hexadiene. In addition to these, we have side branches called propyl. And third carbon propyl is there. Fourth also propyl is there. So that let me mention 3, 4 dipropyl. So entire name will be given. 3, 4 dipropyl, 1, 3 hexadiene, 5 ion. This is the way we have to give the numbering and IUPAC name for the given compound. Move on to any other compound where you can find only the possibility double and triple bonds. The priority obviously will be started from right hand side, being double bond get higher priority over triple, so that 1, 3 diene, and fifth carbon is having triple bond over here. So that if you see these two compounds, triple bond is there on one end, here also triple bond is there on one end, but here in either end is having double bond, so that numbering will be started from the right hand side only. Okay, 1, 3 hexadiene, being 6 carbon chain, hexa will be the prefix over here, hexadiene, and fifth carbon resided with the triple bond, 5 ion is the name. 1, 3 hexadiene, 5 ion is the complete IUPAC name of the given organic compound. Move on to another compound where you can find double bond and methyl side chains as well. When you see this, 1, 2, 3, 4, fifth carbon is having 2 methyl. So that let me mention 5, 5 dimethyl. And first carbon is having double bond, being it is the chain of 1, 2, 3, 4, 5, 6. Hexa is the prefix over here, and first carbon is having double bond, hence 1 hexene is the name of the compound. 5, 5 dimethyl 1 hexene is the complete name of the compound. Move on to another compound where it is the cyclic butane system and having double bond with the methyl side chains over here. If you see this, numbering obviously started from the carbon containing double bond. So the carbon containing double bond proceeded with another methyl substituent, second carbon, third and fourth. So on first carbon you can find methyl, second carbon also you can find 2 methyl. So 1, 2, 3, 4. 1, 4, 4. 1, 4, 4. This is taken as the fourth carbon atom, being it is away from the double bond. So that numbering will be started from this end. 1, 2, 3, 4. 1, 4, 4. Trimethyl, being all methyl only. So the trimethyl is taken over here. And 4 carbon system, we can say cyclo. And 4 carbons bute. And one more double bond is there in the first carbon, so that ene. So let me mention 1, 4, 4 trimethyl cyclobutene is the complete name of the system. This is the way to give the IUPAC nomenclature for the given organic compounds. And some priority rules also we got discussed in accordance with the given functional groups over here, right? So let's move on to question number 2. This is purely the question from organic chemistry, and being it is a part of reagents, we can say. Here is the cyclic lactone system is provided with the double bond O and oxygen, which is called a cyclic lactone, and it is called a fused bicyclic ring system. Whenever this fused bicyclic ring system is treated with the molecule called DDQ. DDQ is the reagent which is the dehydrogenating, used to remove the hydrogen molecule, right? So that mostly aromatization reactions got carried by this one, dehydrogenation reactions carried by DDQ. DDQ is the reagent to remove the hydrogen, so that a saturated compound turned into unsaturated. Here, this compound got converted into C10H12O2. This is the reduced one. And this will be heated over 180 degrees. Higher temperature heating, lactone ring cleavage we can observe. Oxygen got added over here. So in presence of oxygen, this quinone compound when added, another product I will be generated. In this, question number 2, we have to identify what is the compound H, what is the compound I. Let's move on to the sequential order of the reaction. If you see the cyclic lactone upon treating with DDQ, being it is the dehydrogenating agent, the bridgehead hydrogens got removed so that you can find alpha beta unsaturated conjugated system. This is the conjugated system, we can say, where double bond, single bond, double bond, single bond, double bond. 3 double bonds are arranged in alternative manner so that it is a conjugated system which is generated by DDQ. So that is C10H12O2. And whenever 180 degrees heating, 180 degrees heating gives rise to decarboxylation. You can remove the carbon dioxide from this molecule so that it will be turned into a butadiene system. 1,3 butadiene open molecule will be generated. This open molecule, whenever treated with this quinone molecule, it will be participated in the ring closure reaction. How it can be? 4,2 pi cycloaddition. Here it is the 4 pi electron system. It will behaves like a 2 pi electron system over here. 4 plus 2 cycloaddition got carried and we can find a fused molecule like this. Tricyclic angular molecule got generated, and this will be the final product during the chemical reactions in the series, right? So initial lactone DDQ dehydrogenation gives rise to a conjugated double bond system. 180 degrees heating decarboxylation. Whenever quinoline is added, 4,2 cycloaddition got carried, we will get the fused compound. Move on to question number 3. It is the kind of system provided. This is the problem extracted from the NEET 2023 question paper, where IUPAC nomenclature based question again, but it is not related with the organic, rather it is based on periodic table. And name of the compound is given. IUPAC official names also provided. Among all, one of the mapping will be incorrect. That incorrect series we have to identify. Nil, anium. An means 1, nil means 0, anium means 1. Means atomic number of the given element will be 101. If element name is nil, anium 101, it is denoted as a Mendelevium. This is the correct one only. Niltrium. An means 1, nil means 0, trium means 3. 103. If the element atomic number is 103, that is designated as Laurentium. This is also correct mapping. Nil hexium. An means 1, nil 0, hexium 6. 106 is the atomic number. Seaborgium is the name of the compound. Annium. An means 1, an means 1, anium means 1. 111 it might be. Whenever 111 is the atomic number, dermastatium is a wrong naming of that compound. Rather, the 111 chemical element is given by Rg, which is called rheonoctinium. That is called rheonoctinium. So this is the way we have to identify what is the incorrect answer regarding IUPAC official naming. Among all, D4 is the wrong one, so that we have to answer this. Fourth one is the correct answer for this question number 3. Let's see individual IUPAC naming system. If 0 is the digit, that is denoted with the nil. 1 is the digit un, 2 is the digit bi, 3 tri, 4 quad, 5 pent, 6 hex, 7 sept, 8 oct, 9 n. So this is the way naming of IUPAC nomenclature is possible for the various digits. In accordance to that one, 101 nil anium. This is the way we have to proceed, and we will get various naming system for all the compounds as per the IUPAC nomenclature. And if you observe that, in that they mentioned nil anium. Nil anium means 101. So this is the entire periodic table. Nil anium means 101, which is called Mendelevium. That is correctly given. Nil tritium is given, that is 103 atomic number. And Laurentium is the element that is also correctly represented. And another what they mentioned, unnil hexium. Unnil hexium means one. Un means 1, nil means 0, hexium means 6. 106 is the Seaborgium. Most of the transuranic elements are invented by Seaborg, and he got laureated with the Nobel Prize of Inventions. And that because of that honor, one of the element is mentioned with his name. 106 is mentioned as Seaborgium. That is also correct one. And another triple one, unnium they mentioned. Unnium is given by ronantinium, and it is not directly given with RG, rather they mentioned with DS. If DS is correct, that will be 110 atomic number. But 111 is given with DS, that is the wrong map, what we observed over here. Unnium triple one is the dermastadium is the wrong one, rather it is the rheonoctinium. So this is the way we have to identify which is the wrong map over this IUPAC nomenclature and official name of the given compound. This is a question related with the periodic table. For question number 3, option number 4 is the correct answer. Move on to question number 4. This is the question purely given from the organic chemistry, and we have to think wisely in order to answer this one, because there is a confusing factor is there and a very logical question it will be in order to answer this one. And it is also given in the NEET 2023 question paper. Let's solve how can we achieve the final product. The starting material will be the toluene. Methyl benzene is called toluene and treated with chlorine under photochemical conditions. HNU denotes a light photochemical condition. Whenever chlorination under photochemical condition is given, the reaction proceeded with the free radical mechanism rather than the aromatic substitution. You can find a side chain substitution. Here the side chain is a methyl, and the chlorination may occur on carbon of methyl rather than benzene ring. If the same chlorine is added in the presence of AlCl3, that is a Lewis acid, we have to go for the electrophilic substitution and the benzene ring. So that don't get confused, chlorination under photochemical condition, we must go through the side chain substitution, right? Whenever chlorination under HNU, being it is the free radical mechanism and chain mechanism got followed, you will get one atom substitution, so that CH2Cl will be generated. Two-step substitution, CHCl2 will be generated. Three-step substitution, we will get a CCl3 also possible, called chloral. And if the compound is generated X, that is unknown to you, and further treated for water, called hydrolysis, and specific temperature got mentioned 373 Kelvin temperature, so that the final product is benzaldehyde rather than benzoic acid, so that we are not supposed to confuse with the CCl3. So we have to stop the chlorination at this CHCl2 instance only. Let's see why we have to stop here. Why can't we get a complete chlorination of the side chain? Let's see the both the possibilities. If this is the toluene treated with chlorine under HNU conditions called photochemical chlorination, side chain methyl will be substituted through the free radical mechanism, and we have to offer benzol chloride only. Why benzol chloride is required? Why can't we go for CCl3 complete? Benzo trichlorine chlorine why benzoic trichloride can't be achieved? Because if you are getting complete chlorination, all three hydrogens if removed, what happens? Further hydrolysis, all three chlorines got replaced with hydroxy. Upon dehydration, you can find a benzoic acid. But within the problem, they mentioned for benzaldehyde, this is somewhat less oxidized product. In order to get that, chlorination must be restricted. You have to go for controlled chlorination, not excess. Whenever controlled chlorination got treated, you can stop the reaction at the instance of CHCl2. Whenever this called benzol chloride treated with water at 373 Kelvin, both the chlorines now replaced with OH and OH. Subsequent dehydration gives rise to the benzaldehyde as the final product. This is the way we have to anticipate what is the final product, right? So toluene upon treating with chlorine H nu and further hydrolysis benzaldehyde can only achieved by taking benzol chloride as the intermediate compound. For question number 4, option number 3 will be the correct answer. Move on to question number 5. It is also the match the following question. We have to go for the compounds given and their applications. What applications you can find in your daily life. N2O2 is called sodium peroxide. Sodium peroxide is working like an oxidizing agent. Being peroxy bond is very active and we can easily release the nascent oxygen and it works like an oxidizing agent. Deuterium oxide is the isotope of water. So in that water you can find hydrogen. In deuterium is the isotope of hydrogen, where one proton and one neutron will be there. Atomic mass is accorded with the 2, and this is the heavy water we can say, which is also alternative. Deuterium oxide is also known as the heavy water. Heavy water is the moderator in the nuclear reactions. Actually, nuclear reactions are used for power generation. Nuclear reactions are uncontrolled and continuous chain reactions gives rise to the uncontrollable amount of energy. In that instance, we have to go for some precautions. Deuterium oxide, whenever treated, that used to absorb some of the neutrons in the nuclear reaction. Neutrons are very typical tiny particles used to initiate further chain reactions of nuclear fission. If you decrease the number of neutrons, so that number of chain reactions got lowered and we can convert uncontrollable reaction into mild one, controlled one. So that's the reason why deuterium oxide is the moderator in the nuclear fission reaction for nuclear power generation. In either metallic cesium, metallic cesium was given, and it is the kind of S block first main group element. And the application of this cesium will be photoelectric cells. Photoelectric cells are very important, important devices which used to harness sunlight into the electrical power. Solar energy got converted into electrical energy by means of these photoelectric cells, and which can be embodied with the cesium metal so that it is possible to convert a solar light into the electrical energy. Right? This is the way you can go for. And in either magnesium hydroxide called milk of magnesium. This milk of magnesia is very typical example for antacid. If anybody are suffering from the ulcers or any excessive acid production in your stomach, in that condition, the curation is possible by the addition of magnesium hydroxide, and it used to neutralize the acid secretion in the stomach, so that it is the simplest example for antacid. Let's see detailed explanation for all this. Sodium oxide, here all the options are provided in Telugu. ఈ క్రింది వాటిని జతపరచండి. సోడియం పెరాక్సైడ్ అనేది ఆక్సీకరణిగా ఉపయోగపడుతుంది. డ్యూటీరియం ఆక్సైడ్ అనేది మోడరేటర్, తెలుగులో దీన్ని మితకారి అని అంటారు. న్యూట్రాన్లను శోషణం చేసుకోవడం వల్ల కేంద్రక విచ్ఛిన్న చర్యలను ఇది పరిమితంగా అయ్యేటట్టుగా చేస్తుంది. కాబట్టి డ్యూటీరియం ఆక్సైడ్ ని మితకారిగా ఉపయోగిస్తారు. సీషియం మెటల్ అనేది కాంతి విద్యుత్ ఘటాలలో మనం ఉపయోగిస్తాం. సూర్యకాంతిని విద్యుత్ శక్తిగా మార్చే కాంతి విద్యుత్ ఘటాలలో మనం సీషియం మెటల్ ని ఉపయోగిస్తాం. మెగ్నీషియం హైడ్రాక్సైడ్ అనేది ఆమ్ల విరోధి. ఆమ్లాన్ని తటస్థీకరించడంలో మెగ్నీషియం హైడ్రాక్సైడ్ అనేది ఉపయోగపడుతుంది. So this will be the correct mapping of all the list 1 elements with list 2. Let's see one by one. Remember, whenever nitrogen peroxide was taken, in this nitrogen peroxide, what is the sodium peroxide. In the sodium peroxide, here sodium existing in, being it is a peroxide, sodium existing in +1, and it is not possible to get +2 and +3 as well. always peroxy bond is highly unstable and weak it is, and having tendency to release oxygen, so that it is the oxidizing agent, working like a oxidizing agent. And another heavy water called a deuterated water is called heavy water, basically used as a moderator in the nuclear reaction. Whenever uranium-235 bombarded with a slow neutron, neutrons are very essential to initiate nuclear fission reaction. In order to cleave this heavy uranium, a tiny neutron is required. Whenever this kind of reaction is possible, faster moving neutrons will be originated. Whenever faster moving neutrons are originated, they will initiate the reaction on either uranium very rapidly, so that reaction will become explosive. In order to avoid that, one moderator is required. This moderator is a heavy water which used to slow down the speed of that neutron. So here we can optimize the reaction rate. Chain reactions got slowly continued, so that we can encapsulate the energy released from this nuclear reaction. Very essential component. If deuterated water is not used, reaction will become explosive. Huge amount of heat evolved, quantity stored anywhere, that used to give the adverse effects over nuclear reaction, right? And this is about the photovoltaic cells, we can say, where sunlight got converted into the electrical energy by means of cesium. Cesium layers are used over here, being cesium is a most electropositive element in the entire periodic table, so that having strong tendency to release the electrons, and the movement of electrons gives rise to the power. And this is the way we can apply the cesium in the photoelectronic cells. And if you go with magnesium hydroxide is the part of antacid, and whenever it is in contact with hydrochloric acid, so that it will neutralize the compound. Acidic nature of HCl got neutralized in the stomach, because we are secreting HCl in the stomach, which used to give the ulcers in the stomach if proper food intake is not there. In that condition, antacid is required to eliminate the effect of acid. By the addition, we will get the neutralization water in the salt. So by that, question number 5 is completed. Sodium peroxide is the oxidizing agent. Deuterated water is the moderator in the nuclear reaction. Cesium is the metal used in photoelectric cells. Magnesium hydroxide is the antacid for the neutralization of hydrochloric acid in the stomach, gastric juice. Move on to question number 6. This will be the last question of the session. And this is the question given from the material chemistry, where graphite is a material. It is called allotrope of the carbon. Graphite is used as a dry lubricant in the machines which run at high temperature, right? Graphite. So here automobiles or any machinery requires the lubricant. Lubricant might be added either in a greasy condition, waxy condition, solid lubricants added, liquid lubricants, oils can be added. So many kind of different forms of lubricants will be added. Graphite is also the form of lubricant when used in the machinery used to run the vehicle at high temperature conditions. Also high frictions also got withstanded by means of graphite lubricant, and it is a solid dry lubricant. And how can we say graphite is a lubricant? What could be the reason for that? The layers of graphite slip over one another when pressure is applied. Whenever this graphite is used, being it is a layered structure, it is a kind of layered structure. By applying the pressure, by applying the friction, the layers will slide one upon another, so that friction conditions completely avoided. Rather, sliding condition will be provided. It will give the smooth rubbing of one surface over another. That is the reason why. So here graphite is the effective solid lubricant used in the machinery, automobiles, everywhere we can use this one. గ్రాఫైట్ ను అధిక ఉష్ణోగ్రత వద్ద పనిచేసే యంత్రాలలో కందెనగా ఉపయోగిస్తారు. lubricant is nothing but కందెన. So here extremely high temperature they are able to withstand. పీడనాన్ని కలుగజేసినప్పుడు గ్రాఫైట్ లోని పొరలు ఒకదానిపై ఒకటి జారుతాయి. లేయర్డ్ స్ట్రక్చర్ నథింగ్ బట్ ఒకదానిపై ఒకటి పొరల మాదిరిగా అమరి ఉండడం వల్ల, సో దేర్ ఇస్ ఎ టెండెన్సీ ఆఫ్ స్లైడింగ్. సో జరగడం వల్ల అక్కడ ఫ్రిక్షన్ అనేది కంప్లీట్ గా మనం తొలగించవచ్చు. A and R are true. R is the correct explanation of A. So both are the correct answers only. Whatever assertion and reason are there, both are exactly correct. And R is the correct explanation for that assertion, right? So this option number 3 will be the correct answer. If you see this, graphite is provided with the hexagonal layers, 6 carbons containing, 6-membered ring containing layers. You can observe one graphite layer is weakly bonded with another graphite layer with the dotted line bond. Weak van der Waals forces are connecting one layer of graphite with another layer. Whenever force applied upon this kind of dotted line bond, van der Waals forces between them got cleaved, and once one layer will slide over another, so the friction conditions completely avoided. Rubbing tendency can be completely avoided. So for question number 6, option number 3 is the correct answer. By this, we completed the entire session of today's intermediate entrance and competitive examination chemistry. Hopefully, the session will be very much helpful towards your entrance exam or any competitive exam you're aspiring for. Hence, I'm requesting you to kindly like the channel, comment which part is very much helpful for you really, and share with the aspirants who are seriously preparing for the examinations, either entrance or any competitive or any government jobs, etc. And subscribe the channel in order to receive more such kind of updates, more such videos in the near future. Thank you very much for your patient listening. Thank you, one and all.